Morning kids. Today we'll be learning about optimal page replacement algorithm, and we have assumed the reference string as given below. Let us try to understand this particular algorithm more briefly. uh, Again we'll assume the page size as 3 of the page table, which we call it as page frames. So initially, like all the frames in the page table are empty, so therefore a page fault occurs. So it goes to the backing storage device, get this particular frame, and again updates in the page table, and again regenerate the CPU address. So therefore we bring in this 7 frame and place it in this particular page table. Again a page fault occurs, so therefore you don't have the 0. So again a page fault occurs, so you go to the backing storage device, bring in the appropriate frame and update the page table. So therefore 0 comes over here, and again in this particular case again a page fault occurs. So therefore you have 7 over here, 0 over here, 1 you don't have. So therefore you go to the backing storage device, bring in the required frame and update the page table and restart the execution. Now actual problem comes over here. 2 we need to update it in the page table, but the frame 2 is not in the page table. So therefore you need to select the victim and then bring in this particular second frame and update the page table and restart the execution. So therefore what we need to do is we need to check the previous entries over here which to replace. So therefore what you do is 0 is used over here, and again 0 is used over here, here, here and here. At the same time 1 is used over here, here and here. Now we need to again check this particular 7 in the given reference string. Where it is used over here. So therefore what you do is 0 is used before 7, at the same time 1 is used before 7. So therefore you will select this as the victim and replace it by 2. So therefore what you do is you replace the 7 by 2 and retain the other values. Now what we need to do is we need to erase all the pencil marks that what we have done. Now again 0 is referred over here, so already the frame is there in the page table, so therefore a page fault will not occur. Now here the page fault does not occur. So now what we do, we again redraw the page table, that is 2, 0 and 1. Now we need to again check this 2, 0 and 1. So again what happens, 0 is used over here, here, here and here, and again we'll check up with this particular 1 it is used here, here and here, and again 2 is used over here, 2 is used over there, again here, here. So here what we need to do is we need to select the victim. 0 is used before 2 and 1, and again 2 is used before 1. So therefore the selected victim is 1. So you will retain this 2 over here, 0 over here, and 1 should be replaced by 3. Again you refer the 0, so already the frame is there, so therefore the page fault will not occur. Here in this case also the page fault does not occur. Now what we need to do is we need to redraw the page table size and again make the entries. Now again the page table size is full, so therefore 4 has to be replaced by any one of these frames. So therefore what you do, again you check the future reference strings. So for that again erase the pencil marks that what we have done. After erasing all the pencil marks, so what we need to do is we need to again mark the values. 2 is used in the future reference string over here, here, here. So therefore again 0 is used over here, and again here, here, and again 3 is used over here. So now we need to analyze this frames in the page table. 2 is used before 0 and 3, 3 is used before 0. So therefore the selected victim is 0. So what we need to do is we need to retain this 2, replace the 0 by 4 and again retain this 3. Now again what happens, the CPU generates the logical address and or the reference string, that is nothing but 2, which is already there in the page table. So therefore the page fault does not occur. Again 3, again it is there in the page table, so therefore here also we don't have any page fault. Now when I come to this reference string, a page fault occurs because we don't have this 0 frame in this page table. What I have done is I have again erased the pencil marks. Now again when I have to bring this 0 into the page table, I need to examine the previous values of the page table, that is nothing but the frames 2, 4 and 3. So therefore I should refer the future reference string in this particular values. So therefore 2, where it is used in the future reference string, here it is used, here it is used. And again 4, where it is used, 4 is not used in any of the reference string. And again 3 is used in the next value. So therefore what we have to do is we have to select this 4 as the victim and replace it by 0. So 2 remains as it is, 4 is getting replaced by 0, and 3 you have it over here. So therefore when you refer to the next CPU logical reference string, then you do have 3 is already there in the page table, the required frame is there, so therefore a page fault does not occur. So therefore a page fault does not occur over here. And again over here 2 is already there in the page table, so therefore the page fault does not occur. So therefore what you will do, you will put a small into mark over there just for our reference, like how many page fault does not occur. And again 1 is referred over here. Yes, of course a page fault occurs. Now what we need to do is, because one page fault does not occur, page fault does occur. Why? Because there is no one frame in the page table. So therefore again what I'll do, I'll erase this tick marks over here, and after that we need to write the table. Now the problem here is like 1 I am referring, but 1 is not there in this page table. So therefore I need to examine the previous values of this 2, 0 and 3 in the future reference string. So what I'll do, 2 is used over here, and nowhere it is used apart from here. So 0, again 0 is used over here and here. 3, again 3 it is not referred over here, so therefore the selected victim is 3. So now what I need to do, I need to retain this 2, and again I need to retain this 0, and again what I'll do, I'll bring in this particular 1 over here. The next CPU reference is 2, so therefore again you will check up this particular page table. 2 is already there, so therefore page fault does not occur. So therefore you will put an into mark over here, and again 0 is referred, so therefore 0 is already there, so therefore the page fault does not occur. So therefore you will put an into mark over here, and again 1 is referred here, which is already there in the page table, so therefore a page fault does not occur. So now what happens, now I am referring to the 7. So now what I need to do, there is no 7 in this particular page table. So that what we need to do, we need to select the victim and replace it. So now the future reference string is 0 and 1. So therefore here what you will do, 0 is already used over here, and again 1 is already used over here. So therefore the only frame which is not being used is 2. So therefore what I will do, in place of 2 I will bring in the 7, and I will retain the 0 and 1. So the next reference string is 0, so which is already there in the page table, so therefore the page fault does not occur. And again 1 is the next reference string, so therefore you already have 1 in the page table, so therefore the page table does not occur. Now what we do is we try to compare the number of page fault occurred and the number of page fault which did not occur. All the into signs refers that the page fault did not occur, and all the blocks that what we have written does signify that the page fault has occurred. By looking into this comparison of page fault occurrence and as well as no page fault occurrence, so compared to the other algorithms, we judge that this particular algorithm is the optimal or the best algorithm when compared to the other algorithms. But here it also has a negative point. What is that is, How do we know that the future reference string that I am going to refer? Here, only if we know the future reference string, then only this particular page or page replacement algorithm, optimal page replacement algorithm, can be implemented. Otherwise, we do have difficulties in implementing this optimal page replacement algorithm. Thank you all.